Welcome to the video for section 7.2 in the ITV program at LACCD. This section of the book covers solving systems of equations. This method is going to be a little different than the one we looked at when we were looking at solving things by finding the intersectional lines. This method works with solving these with what we call substitution. And sometimes that method can be done pretty easily, and sometimes that method will take a little bit of extra work. Well, let's dive in and let's see exactly how that method of substitution works. So we're told to solve the system of equations by using the substitution method. We're given the following system here. I'll just write this down. We have x plus y is equal to 4, and then we have x equals 3y. So when we're solving by the method of what's called substitution, what we're going to do is we're going to pick one equation, or one of the two equations, ideally where the variable is either by itself or an equation where we can manipulate it to get a variable easily by itself. In this first problem, it appears that in the second equation, we already have x by itself, and that's equal to 3y. Well, since x is equal to 3y, what I'm going to do is I'm going to replace this x up here with what it's equal, and that's 3y. So if I have x plus y equals 4, and I know that x is equal to 3y, I can then replace x with 3y plus y equals 4. Now the nice thing about that is, instead of having one equation with two unknowns and this equation with two unknowns, this will give us now an equation that has only one unknown, that's y. So we're going to have 3y plus y, and that'll give us 4y equals 4. And this is pretty easily solvable at this point. So we go ahead and divide both sides by 4, making sure that it can be seen, and then move it up a little bit. And when we put that through, we're going to get y is equal to 1. Now we know the value of y, we still need to find the value of x. Now, because I substituted it into the second equation, here, I can really use either equation, but I need to use one of the originals. So what I do with this often, and it's kind of a check just to make sure that we have the right value of y, I'm going to go ahead and write each of the original equations down. And I'm going to take this value of y and put it in to each, and I should get the same value of x. If I do, then chances are I've got the correct value of y that I need to seek, and we should obtain the correct value of x. So here that's going to give us x plus 1 is equal to 4. And over here I'm going to get x is equal to 3 times 1. So if I do this, I'm going to get x is equal to 3 here. Well, here I should get x equal to 3 also. If I rewrite this as x plus 1 is equal to 4, and then I subtract 1, I should get x equal to 3. Since I get x equals to 3 for both of those, we can say that this one is going to work, and that means the solution to this system is going to be 3, where x is equal to 3, and where y is equal to 1. And we'll write the solution to the system as a point, like we did in the previous section. And the solution is going to be 3, 1 as an ordered pair. So mentions here for the solution, the type is an ordered pair. That'll be 3, 1. Let's go and take a look at another question. This is going to be a different type of substitution. Take a look at number 2 now. Let's see, move it up a little bit. Okay. This one says to solve the system of equations by the substitution method. We see here we have two equations that are both set equal to y, where y is equal to 4x plus 7, and then y is equal to 9x plus 8. Well, since they're both equal to y, what I can do is I can replace this y up here with the value of y here, which is 9x plus 8. So what I can do is I can put in place of this y 9x plus 8. So I can say 9x plus 8 is equal to 4x plus 7. So I'm going to go ahead and just do the work here. I'm going to move my number to the right. I'm going to move my variable to the left. That's going to get us 9x minus 4x equals, this is going to be plus 7, and this is going to be minus 8. Okay, and if I'm correct here, I think I'm going to be looking at a fractional value. Okay, so make sure I have this all copied down correctly. Yep, looks like I do. So 9x minus 4x is going to give me 5x. Plus 7 minus 8, that's going to give me negative 1. So for x, that means that my value of x now, if I divide both sides by 5, x should equal negative 1 over 5. Yeah, not a terribly pleasant value to work with at this point, but it is a value. So I'm just going to double check my work here to make sure that I've done everything correctly, and it looks like I have. So we have x is equal to negative 1/5. So we're going to have a not particularly nice value of y when we're going to solve for that. Now I'm going to take this value of x now, and I'm going to put it in for y equals 4x plus 7, and then y equals 9x plus 8. When I start getting fractions for answers, I start getting nervous about my results. But let's see what the answer turns out to be once we sub this in. So we're going to have y equals 4 times negative 1/5 plus 7. And again, if you do this in your calculators, convert your answer to a fraction, they should come out to be the same if I've done my work correctly. Then this is going to be 9 times negative 1/5. And I'm beginning to have confidence in my work here now. I think I've done this correctly. I'm going to add 8 to that. So if I multiply this together, that's going to be negative 4/5 plus 7 here for y. Over here, I'm going to have negative 9 over 5 plus 8. Okay, and this is going to work out. This will be like 35 over 5 minus 4. That'll be equal then to 31 over 5. This will be like 40 over 5 minus 10 over 5. This will be 31 over 5. And again, I wouldn't expect you to do this on paper. This will be the kind of calculation that you have a calculator. It will do it for you. Since we do obtain the same value y from both equations, we can say that the solution to this system is going to be negative 1 over 5 and 31 over 5. That would be a kind of a solution that would be difficult to obtain with graphing. You could obtain the intersection point, but from a graph it would be difficult to see upon inspection exactly what those measurements would be. This would be something that we either have to do by substitution, or the next method we're going to learn about, which is called elimination. So the solution to this problem is going to be negative 1/5 and negative 1 over 5 and then 31 over 5. As I go through these questions here, if you ever want to, you may pause the video and try some of these on your own. We're going to go to question 3 now, and I strongly encourage you to practice these techniques. Once you get the gist of this, try these on your own before you continue to watch my video so you can see how these work. So in question 3, we have 7x minus 2y equals 20, and we have y equals x minus 5. So since I know y is equal to x minus 5, I'm going to substitute in for that y right there. And that'll give me, I'll write the equation first as it was written, minus 2y equals 20. I'm going to replace that y with what is equal to here, which is x minus 5. That's going to give me 7x minus 2 times x minus 5 is equal to 20. So I'm taking this value from the second equation and I'm substituting it into the first equation in the system. I'm going to go ahead, I'm going to distribute negative 2 through there. So that'll give me 7x minus 2x by distributing. And then negative 2 times negative 5 will be plus 10. That should be a 7, guys. My apologies there. Okay, I meant to put that as a 7. So watch out. That's a 7x coming from here. I distribute to get these other two terms. That'll equal 20. From this side, I need to move the 10 over. So I'm going to have 7x minus 2x equals 20 minus 10, because I'm moving this positive 10 over here to become negative 10. And then when I combine my other terms, I'm going to get 5x equals 10. If I take both sides and divide that by 5, I should get x is equal to 2. So again, just to make sure that I've obtained the same value of x, I'm going to use both equations from what's given to me originally. That's 7x minus 2y equals 20. And then y equals x minus 5. And I'm going to put x in both of these to make sure that I get the same answer. And if I get the same value for y, then I have the same correct value of x. So this is going to be 7 times 2 minus 2 times y equals 20. And then here I'm going to have y equals 2 minus 5. I'm going to go with this one first. This is going to be easier calculation. Just make sure to do this in your calculator, please. 2 minus 5 should yield negative 3. Let's see what this brings over here. 7 times 2 is going to be 14. Minus 2y equals 20. If I move the 14 over to get negative 2y equals 20 minus 14, negative 2y is equal to 6. And then if I divide both sides by negative 2, I should get y is equal to negative 3. And because I have the same result in both, I can say with confidence that the solution to this system is going to be 2 for x and then negative 3 for y. And that's another example of how the solving by substitution will work in this problem. Let's go ahead and take a look now at question 4. Question 4 is where the solving of a system of equations by substitution becomes a little more challenging, but not too bad. So I'm going to go ahead and I'm going to rewrite this problem again on my paper here. So I'm going to have x plus 6y is equal to 26, and I'm going to have 3x plus 4y is equal to 8. So as the problem is given to us now, we don't have any one variable by itself. So what we need to do is we're going to need to manipulate one of these equations to get a variable by itself. And usually, not always, but usually, one equation is going to be easier to manipulate than the other. And I'm wondering what you think will be the equation we're going to choose to try to get a variable by itself. You want to pause the video and see if you can figure this out? Go ahead. If you paused and we're coming back to this now, I would select the first one to try to get a variable by itself. So I'll say x plus 6y is equal to 26. And the reason that is because since x is alone, if I go ahead and move 6y to the other side, I can write x as being equal to negative 6y plus 26. If some of you chose to write this as x equals 26 minus 6y, this is also appropriate. I'm just choosing to write it like so. Hold on, 6y, not x. Okay, yeah, there you go. So that's a y there. So I just choose to write it like this. So what I'm going to do now is, since I've rewritten the first equation, I'm going to take the variable I have by itself here, and now I'm going to put it into the second equation. So that I know x is equal to this mess, and I'm going to substitute x into here. So this is going to be 3 times. What's x equal to? Negative 6y plus 26. And that's going to be then plus 4y is equal to 8. You see, on some of these, the equations can get pretty complicated. So on this one, we're first going to have to distribute through. That'll be negative 18y. 3 times 26, that's going to be 78. I'm going to bring everything else down then. Plus 4y equals 8. I'm going to go ahead and move the 78 over to the other side. So I have negative 18y plus 4y equals 8 minus 78. When I go ahead and I combine like terms, and I just move this up a little bit to make sure I continue to show my work, this will give me negative 14y, and this is going to be negative 70. If I divide both sides by negative 14, I'm going to get y is equal to positive 5. 70 divided by 14 is 5, and then a negative divided by negative is positive. That should be my value of y. Well, remember, if we're going to, if we want to be certain about this, we're going to go ahead and we're going to write out both equations to substitute this in and ensure that we get the same value of x from both. So my first equation is going to be x plus 6y equals 26, and the second one is going to be 3x plus 4y is equal to 8. So if you look at other videos, what they're going to do is have you check your solution This method not only obtains the right value for both equations, it also takes away the need to check, because when you test this value in both equations and you get the same value, the check is built into that process. You wouldn't obtain the same value in both of these unless you had the correct value of y. If you obtain a different value in both of these, like from this one to this one, and you have a different value for x in this case, that probably means that you have the wrong value of y. It could also mean that you've done some algebraic work here incorrectly, so you want to double check that. All right, let's go ahead and put y equals 5 into each of these, and let's see what we get. So here, once we substitute y into here and here, that's going to be x plus 30 equals 26. Here we're going to have 3x plus 20 equals 8. If I move things over, that's going to give me x is equal to 26 minus 30. Here I'm going to have 3x equals 8 minus 20. Here x is going to equal negative 4. Let's see if we obtain that same result here. Here I get 3x is equal to negative 12. And then if I divide by 3, x will equal negative 4. Since we obtained the same result, we can say with confidence that we have a solution for this system, and we can write that solution as the ordered pair x and y of negative 4, 5. You can see from the level of work here, there's a lot of algebra going on. So, but this is how we solve a system of equations, at least by the method of substitution. Now, when you're asked to solve a system by substitution, you must use that method. If you're doing a test like the final exam and you use a different method to solve it, you'll be awarded at most 1 point for at least obtaining the correct answer. But when we ask for a type of method of solution, we're assessing your ability to use that method of solution, because not all methods work for all systems, so we want to know that you can apply that method correctly. Okay, so we're going to go to question 5 now, and we're going to, I would like you to stop the video if you want to try this one before you go ahead and see the solution to this worked out. Let's see what you can do. Okay, so what I'm going to do with this one is I have 5x plus 4y equals 37, and I have x equals 2y minus 1. This one, hopefully you see, is a fairly straightforward substitution. I'm going to take the second equation, the value of x equals 2y minus 1, and put it into the first to get 5 times 2y minus 1 plus 4y is equal to 37. And let me save the space over here when I need to put y into those two equations. By distribution, I'm going to have 10y minus 5 plus 4y. I'll distribute that through here, get this, plus 4y equals 37. I'm going to go ahead and move the 5 to the other side, so 10y plus 4y equals 37 plus 5. And this is going to give me 14y equals 42 when I combine my like terms on each side of the equal sign. Now that I'm going to divide both sides by 14, I'm going to get y is equal to 3. Well, I want to check that result now, so I'm going to write each equation, and I write the equation as they originally look in the system. So like in the previous problem, we had to change the equation a little bit. But when we find a value for one of the variables and we want to find the value of the second variable, we use the original equations that we get from the system. 5x plus 4y equals 37, and then x equals 2y minus 1. So this is going to be 5x plus 4 times 3 equals 37. This is going to be x equals 2 times 3 minus 1. Well, this one's probably going to be the easier one to work with. 2 times 3 is 6 minus 1. X should equal 5. Let's see if we get the same value for x over here now. So I'm going to take 5x plus 12 equals 37. If I write this as 5x equals 37 minus 12, 5x equals 25. And if I divide both sides by 5, x is equal to 5. And indeed, I obtained the same value of x for both of these. So my ordered pair that's going to be a solution for this system is going to be 5, 3. Okay, we have question 6 now. So if you'll take a look in question 6, you'll see that we don't have either equation that has a variable entirely by itself. So if you would, take a moment to pause the video and see if you can find an equation that you can manipulate easily enough to get one of the variables by itself. Hopefully you've done that. And if you want to also just pause the video and then just try to work this problem through the end, you can take an opportunity to do that as well and see how you do. Or you can just go on and let's work on the solution together. So if I have this following system, 5x plus y equals 16, that 8x minus 2y equals 4, the equation in the system that's going to be easier to manipulate to get a variable by itself is going to be the first one, because we have just y by itself here. So I'm going to go ahead and take 5x plus y equals 16. And I'm going to move the 5x to the opposite side, making it y equals negative 5x plus 16. Since I manipulated the first equation, I'm going to take what I get here and put it into the other equation. So what that's going to give me then is I'm going to take the value of y I know here. I'm going to put the value of y into this. So that'll give me 8x minus 2. What's y equal to? Negative 5x plus 16. And that's going to equal then 4. Okay? So I took this value of y and I put it in right here. You get 8x minus 2 times this equals 4. Now I need to work with this and manipulate this around a bit. So I'm going to have negative 2 times this. That's going to be positive 10x. Negative 2 times positive 16, that's going to give me negative 32. The rest of the equation here I'm going to bring down. What I didn't manipulate from here to here, that'll be equal to 4, and we bring down 8x. From this point here, I'm going to go ahead and move the negative 32 to the other side, so it's going to be 8x plus 10x equals 4 plus 32, because I move this negative 32 to the other side, I switch the sign. That'll give me 18x equals 36. If I divide both sides by 18 to solve for x, I'm going to get x is equal to 2. Now we're going to go ahead, we're going to put this into both equations now and see if we obtain the same value of y. So we're going to have 5x plus y is equal to 16, and then we're going to have 8x minus 2y is equal to 4. So since x is equal to 2, we're going to have 5 times 2 plus y equals 16. Then 8 times 2 minus 2y equals 4. So here we're going to get 10 plus y is equal to 16. Here we get 16 minus 2y is equal to 4. And let's see if this gives us the same value of y. Well, I'm going to move 10 over to the other side to get y equals 16 minus 10, or y should equal a positive 6. Here, if I move 16 to the other side, that's going to give me negative 2y equals 4 minus 16, or negative 2y is equal to negative 12. And if I divide both sides by negative 2, I get y equals 6. Because remember, negative divided by negative is positive. Since we obtained the same value for y, we can say that the solution is going to be the ordered pair 2 and 6. Okay, I'm going to keep working through these. By the way, I found historically that this method of solution tends to be the least popular among students here. Okay, so because the math is usually fairly sophisticated, so I want to make sure to provide ample examples for everyone to look at in order to help you with your homework here. Let's take a look at number 7 now. Excuse me. So we have the following system here: 8x plus 4y is equal to 2. Then negative 2x equals y plus 4. Again, we don't have a variable by itself, so I'm going to encourage you to pause the video and see if you can find the equation we need to manipulate to get a variable by itself. And if you can identify that, then try to work the problem out on your own. You can pause the video this time and then come back, or you can continue to watch. All right, so what we're going to do from here is, this time, to find a variable to get by itself, I think the second equation is probably easier because the y at least doesn't have a number next to it. Like, it's not 3y or 5y or 1/2 y. It's just y and then plus 4. So I'm going to pick the second equation to manipulate, and that's going to be negative 2x equals y plus 4. Because I want to try to get y by itself, I'm going to go ahead and move 4 to the other side. And what that's going to give me, if I do that, is going to give me negative 4 minus 2x equals y. Not a particularly nice value with all those negatives dangling there. So since I manipulated the second equation to get y by itself, I'm going to take this value of y and put it into the first equation. So my first equation reads 8x plus 4y equals 2. Well, since I know the value of y here, I'm going to replace this y with negative 4 minus 2x. So it's going to be 8x plus 4. And by the way, if you have negative 2x minus 4, that works also. Negative 4 minus 2x, and it equals 2. So I replace this y with this value here. And we need to do a little distribution now. So it's going to be 8x minus, this is going to be now minus 16, plus 4 times negative 2 is going to be negative 8x, and that'll equal 2. Again, on this one, what I'm going to do is I'm going to move the negative 16 over there. That's going to give me 8x minus 8x equals 2 plus 16. Now this one presents a little bit of an interesting solution. This is going to give me 0 is equal to 18. Well, you should know that since 0 is not equal to 18, this is impossible. And what this means is, regarding this system, is that there is no solution. So if we can't, if this works out such that we get a variable that disappears entirely, we can say that there's going to be no solution for this system. So that's going to be the answer here for question C, or question 7, excuse me. All right, let's go and take a look at question 8. Again, I will encourage you to stop the video and see if you can find which equation you should try to manipulate to get a variable by itself, because there isn't one here that is by itself as it's currently written. So stop the video, see if you can find it, see if you can solve the problem, and then come back. All right, so hopefully you chose the first one, and we'll write 7x plus y equals 20. If I move the 7x to the opposite side, that's going to give me y is equal to negative 7x plus 20. And because I manipulated the first equation, I'm going to take this value of y and put it into the second equation now. So I'm going to take the second equation, 8x plus 4y is equal to 20. And I take this value of y and put it into here. It'll be 8x plus 4 times negative 7x plus 20 is equal to 20. And let's see what kind of result we get for this now. So if I distribute 4 through this will give me negative 28x. 4 times 20 will be plus 80. And I'm going to bring everything else down. 20 and then 8x. So I'm going to go ahead and bring the negative 80 over. So let me push this up a little bit. So it's going to give me 8x minus 28x equals 20 minus 80. I bring this 80 to the other side. So this gives me negative 20x equals negative 60. And if I divide both sides by negative 20, I should get x is equal to positive 3. Once I get the solution of x equal to positive 3, I can sub that value of 3 into both of these equations. Again, I'm going to put them into the original equation, not the ones there, the ones here. So I'm going to write both of those down here. So I'm going to have 7 4x plus y is equal to 20, and then 8x plus 4y is equal to 20. And we should obtain the same value for y if our x is correct. So it's going to be 7 times 3 plus y is equal to 20. And then we should have 8 times 3 plus 4y is equal to 20. And yeah, I think this is going to work out okay. So this is going to be 21 plus y is equal to 20. This is going to be 24 plus 4y is equal to 20. Now, if I'm going to move this over, so I'm going to get y is equal to 20 minus 21, or y should equal negative 1. So we should be looking for a negative 1 over here, if this is the correct value of x. So I'm going to write now for y is equal to 20, bringing this over here is going to be minus 24. That's going to be 4y is equal to negative 4. And then if I divide both sides by 4, y will equal negative 1. So making sure that I get the same answer here, my solution for this system is going to be 3, negative 1. And that's going to be question 8, worked out completely. Yes, guys, you'll notice that this video is going to be longer than normal one because I know solving by substitution, again, is one of those subjects that's a little more daunting for students. I just want to make sure that I give students ample opportunity to work on this. What I'd like for you to do is go ahead and take a look at number 9. Again, one of these equations is going to be easier to manipulate than the other to solve a system. Stop the video, see if you can find which one is easier to manipulate it, and then see if you can work on the problem all the way through. Hopefully by this time you're going to be able to get the hang of this and able to execute this well. Alright, so for this first one here, I'm going to go ahead and work with the second equation. And what I'm going to do is I'm going to write this as x plus 5y equals 0. Or if I just bring the 5y to the opposite side to get x by itself, I'm going to write this as x equals negative 5y. So since I manipulated the second equation, I'm going to take this value of x and put it in the first. So if I'm given 3x minus 3y is equal to 1, I'm going to put this value of x in for here. So it's going to be 3 times negative 5y minus 3y is equal to 1. So this is going to be negative 15y minus 3y is equal to 1. And just to let you know, ladies and gentlemen, I don't think this is going to be a very pleasant answer. Sometimes this gives me pause when I see these in my work. Alright, so when I combine this, it's going to be negative 18y is equal to 1, which means when I divide by negative 18, my value of y is going to be negative 1 over 18. And like I said, I don't particularly like solutions like this, but we're going to give this a try and see how this works out. Again, if you have a calculator, you should be able to work with these calculations pretty fluidly using, if you have a scientific calculator, it should work out pretty nicely. So I'm going to write both equations here. 3x minus 3y is equal to 1. X plus 5y is equal to 0. So here we have 3x minus 3 times negative 1 over 18 equals 1. And then we're going to have x plus 5 times negative 1 over 18 is equal to 0. So now if we do these calculations on the calculator, this is going to give you 3x plus 3 over 18 is equal to 1. This is going to be x plus, or sorry, minus, because you're multiplying a positive times a negative. So this is minus 5 over 18 is equal to 0. Now the easier one to get the solution to is going to be this here, because once I move this over to the other side, I'm just going to get x is equal to 0 plus 5 over 18, making x equal to 5 over 18. Write that more clearly. I should be looking for 5 over 18 over here. Okay, so What I'm going to do in this case here, I'm going to go ahead and move this 3 over 18 here. So we have 3x is going to equal 1 minus 3 over 18. If you clean this up here and do this on your calculator, make sure to convert, if you get a decimal, convert it to a fraction. We're going to get 3x is equal to 15 over 18. Now, if you do this on a calculator and you take both sides and divide it by 3, here you're going to get x. 15 divided by 18 times 3 will give you 5 over 18. And that's going to work out to be the correct answer. So we have 5 over 18 in both of these. So our solution to this is going to be 5 over 18 and then negative 1 over 18. Okay. So again, I'm not going through all the fraction facts. I don't want you guys worried about that because you have a calculator to take care of this. My expectation is you know how to use your calculator in order to account for the fractions involved in this question. Question 10. So notice in this question here we have a fraction in the problem. Okay. So at least a fraction, I should say a fractional coefficient on the x in the first equation. Now in this problem you can pick either equation to try to get a variable by itself, but one is still going to be easier than the other. And I'm going to give you a chance to pause the video and pick which one that's going to work for. Okay, so hopefully you've paused and you recognize that the easier one to solve and to get by itself is going to be in the second one here. So if I take x minus 5y is equal to 25, I can move the negative 5y over, and when I do so, I'm going to get x is equal to 5y plus 25. Everything is positive, the x is by itself. Up here, if you do that, you're going to have to move negative 15x to the other side and then multiply everything by negative 1. Not a clean substitution. Let's see how this works out when we take this value of x and put it into the other problem. So we manipulated the second equation. We're going to do the substitution into the first equation. So this is going to be 1/5 times, what's the value of x? 5y plus 25, and then minus y is equal to 5. Let's see how this works out here. So if I multiply 1/5 times 5, that'll give me just y. 1/5 times 25, that's going to be y plus 5. So I distribute that through. I'm going to bring down the minus y. I'm going to bring down the 5. I see where this is going. If I move this 5 over to the other side, that's going to be y minus y equals 5 minus 5. And what you're going to see here is we're going to get 0 is equal to 0. When you have a situation like this where the variable drops out and disappears, in an earlier problem, we noticed that we had two numbers that were not equal to each other. And we said that nothing would be a solution. In this case, both numbers are equal to each other, which means that this is going to have infinite numbers of solutions. There are infinite many solutions, and that's going to be choice B in question 10. Finally, the last question. Notice this is going to be another word problem that you're going to have to do. So let's go ahead and take a look at how we do this, and this will wrap up the video when we're done with this. At least I think this will wrap up the video when we do this problem. Yes, it will. The last one we got to do here. Okay, let's double check. Yes, it is. Okay, so write the following as an equation and then solve. Okay, very close or similar to the question that was, I think, in an earlier problem in chapter 6. Twice the sum. So we talk about twice. Remember, we said twice is 2 times. We talk about the sum. So the sum of two things, and that's going to be a number and 4. So that's a number and 4 is equal to. So is equal to is probably actually the first part I should have identified. So we know that we're going to write this out as one thing, and they're going to write this out as other thing. 3 times. So 3 times what? 3 times the difference. The difference of what? The number and 8. So it's going to be the difference of a number and 8. So that's going to give us 2 times x plus 4 equals 3 times x minus 8. So I think I'll just leave that for you guys to solve on your own. The big help there is how we take that word problem and construct it from here. So again, to look at it, find the either is or is equal to, put a parenthesis there so you could chunk and look at this side first. Twice what? The sum. put the sum together in parentheses. Here, this is 3 times. 3 times the difference of a number and 8. And once you put that equation together, this should be something at this point that you should be comfortable with solving. That wraps up 7.2. 7.3 will be coming up soon.